In college algebra today, we looked at ellipses, or the ellipse. This is chapter 7. It's called conic sections, and we're going to look at different graphs. So this ellipse is like an oval. And I'm going to cheat. I found a cool shape-making tool on this program on my iPad. So feel free to draw it freehand, but I'm going to cheat and draw this ellipse, and let's draw one that's taller than it is wide. All right. Am I able to move that? I don't think I can. So the longer dimension is called the major axis. So likewise on this tall one, this distance here, that is the major axis. It does have a center. So let's guess, it's about right there. And we're going to use variables h and k for the center. And the center on this one is about right there at hk. It has a major axis, which means it also has a minor axis. So this on the tall one is going sideways. And this one is going vertical. That's kind of crooked. Let's try again. A little better. And that is the minor axis. We have one other dot on here, and it is for the foci. So that is almost at the end of the either side of the major axis. So you make two dots. We're going to be kind of random when we do this on this picture, but we'll be more precise in a minute. And these are called the foci, and those actually are what make the ellipse. So imagine these arrows right here are a string. Imagine it's one string, those two black arrows, and then you attach your pencil to that angle right here, and you pull it around. Like, imagine the two red dots are like thumbtacks on a board, and your pencil is where that black dot is, and you can pull that string around and it creates the ellipse. So those two red dots are called the foci. All right, we're going to look at how to calculate all that stuff. It's pretty simple. You're going to go off of this standard formula down here, or you have two choices of a standard formula. It depends on if it's wide or if it's tall. So the first formula there, if it's wider than it is tall, then you use that formula. Now that still doesn't tell you enough. So go off of the larger denominator. If larger denominator is under x, it is wide or wider. If the larger denominator, first let's write this, taller, taller than it is wide. If larger denominator is under the y, right. There's some formulas there. Notice to find the foci, we're going to do kind of the Pythagorean theorem. Not really, though, because we're going to go a squared minus bc. You have some coordinates there for the major axis, but we'll look at an easier way to do it. Let's try number 1. In number 1, we have our equation here. We need to write down some coordinates. Now notice that the numerators there, the x and the y, there's no parentheses. Way different from what you see in the formula. For example, if we were to look at number 3, that one looks a little bit more familiar in regards to the formula. So that one's got a center. It's at 1, -2. But number 1, it just looks weird without those parentheses. But it's because h is 0 and k is 0. So if you flip back to page 1, it says x minus h and y minus k. If there's nothing there, it just means that our center is at 0, 0. So make a dot on 0, 0. The larger denominator is under x, so this one is wider. Because 9, the larger denominator, is under x. So that means my major axis is going left to right. So you write down a squared, and you find a, which is easy, that's 3. You write down b squared, which is 4. That one's also easy, it's a 2. And you plot those points. So we're going to go right 3, left 3 for our major axis. We're going to go up 2 and down 2 for our minor. And we're close to done. Notice you don't really need that formula for the major axis. We see that it's at 3, 0 and -3, 0. For the foci, we need to do that c squared equals a squared minus b squared. So we go 9 minus 4, and we get 5. So c is the square root of 5. You're welcome to write square root of 5 in the blank, but it's hard to graph square root of 5. So let's type it in, and we get 2.2. So I'm okay with either of those numbers going in the blank, and we count 2.2 to the right and 2.2 to the left. And connect the red dots. All right, I'm going to give this a shot. That came out all right. And that's our first ellipse. All right, let's try another one. We'll go a little faster on this one. This one looks really different. They're not always set up perfectly for you. So one rule is we need a 1 to be all by itself on one side. And we don't have that. So that 400, that constant, we could divide by 400 and we'll have a 1. Now if we do that, we got to divide everything by 400. So let's divide this by 400. That by 400. And the constant by 400. And we get 1 on the right side, which was the reason for all of that. When we reduce, we happen to get really nice numbers. There are 16 25s in 400, and there are 25 16s in 400. 25 is larger, it's under the Y, so this is taller. Because 25 is under Y squared. All right, looks like we have another center at 0, 0, because I don't see parentheses up at the top. So make a dot at 0, 0. A squared is 25. So A is 5. B squared is 16. So B is 4. So let's go this time up 5, down 5, right 4, left 4. And now we need the foci, or let's write our coordinates down. 0, 5, 0, negative 5. Be careful when you write those, don't mix up your x's and y's. And then lastly, c squared equals 25 minus 16. We get 9, a nice foci this time. So it is 3 units from the center. Let's make a dot at go up 3, down 3. And connect our red dots. The last one was better. Oh well. All right, see y'all later.